The values of a continuous function f for selected values of x are given in the table above. What is the value of the left Riemann sum approximation for the area under the curve from 0 to 40, using the subintervals from x is 0 to 10, 10 to 25, and 25 to 40? The first step to finding the area approximation is to go ahead and find the width of our rectangles that we're making. So we'll go ahead and take the values in each of the intervals that we have, all our subintervals, and we're going to go ahead and subtract them from each other. So we have the 10 minus 0, we have 25 minus 10, we have 40 minus 25. And so these are the ranges for each of our subintervals, or the width of our rectangles. Now to find the heights of our rectangles, we can go ahead and we have to use the chart for that. Now, since we're using the left Riemann sum approximation, we actually have to use the lowest value in our range. So, looking at our first one, the range is from 10 to 0. So, looking at our chart, looking at 0 and 10, 0 is the smallest number, so it would be the leftmost. So, the height of that rectangle would be 4. And then, looking at our next subinterval, from 10 to 25, 10 is our smallest number, so it's our leftmost value. So the height of our rectangle would be 6. And our last subinterval from 40 to 25, the smallest number is 25. So again, that's our leftmost number. So the height of that rectangle is 15. Now we can just go ahead and reduce these down to find the area for each one of our rectangles we've made. So 10 minus 0 is just 10. 10 times 4 is 40. 25 minus 10 is 15. 15 times 6 is 90. Now 40 minus 25 is 15. And 15 times 15 is 225. So now we have the area of each one of our rectangles. To find our total area, we just go ahead and add these three rectangles together. So we add the 40, the 90, and the 225, and that gives us 355. So our area approximation for this situation is 355.